Another edition of Math Magic with Jen. Today we're doing harder multiplication problems that use area models and partial products. And if that means nothing to you, by the end of this video, it will mean something. So let's go ahead and look at what we're talking about today. So like harder multiplication problems, when you have you could see here, 1,623 times 8 or 62 times 35, you probably remember like the standard algorithm. So for this first one, we teach, or hopefully you remember, that we take 8 times 3, we get 24, but we just write the 4 and carry the 2, right? And we keep going. So a couple things before we start off, that's that students need to be fluent in their multiplication or times table facts to make this go really well. So if you have students that are really struggling with their times table facts, it's going to compound. That's not to say they won't be successful, but just make sure that they're practicing, that they're getting better at them. If they're struggling with a particular number, like if they need help with their 7s or their 9s, if they're working on it. But what I want to do is I want to show you how we're going to teach the standard algorithm, but we're going to use what are called area models, okay? And the area model is going to work for both this one and this problem as well. So like when we teach 62 times 35, so a 2-digit number times a 2-digit number, how do we show that? So I guess the first thing we should talk about is what's an area model? So when you look at the teacher resources for Common Core curriculum, if you've never looked at it, I totally understand. When I was asked to teach this in my college classroom, I had no idea what this referred to. So I had to go dig. And this is the picture that I saw in the teacher resources. So I had to kind of figure out what was going on. So at first glance, I thought it was a tape diagram, but tape diagrams don't have kind of these numbers on the outside. And area means something very specific. So once I dug a little bit, kind of looked at what was happening here, what I noticed first off is that this number across the top was written in expanded form. Okay, so we have our 1,423. Okay, what about this number 3? It's here. As I started to investigate these little rectangles, I noticed that the rectangles went bigger to smallest. So the 1,000 box is a little bit bigger, whereas the 3 box is a little bit smaller. So I think that was intentional to show size. And what they're doing is they're using the area of a rectangle. So an area of a rectangle is length times width or base times height. And so the idea here is that students are going to take this 3 out front times this 3 on the outside. The area of this little box would be an area of 9, okay? Notice the next one, 20. 20 times 3 is 60. 400 times 3 is 1,200. And 1,000 times 3 is 3,000. So to kind of sum up what we've looked at so far, we're going to draw a skinny rectangle, kind of like a tape diagram. You're going to write expanded form across the top and the number that we're multiplying by out front. We're going to calculate the area of each piece by just multiplying the number on the top of the box times the number out front. Okay, now here's where I haven't shown you the final answer. The final answer is you're supposed to add all the numbers on the inside. So here, that would be adding 3,169 together and seeing what we get. Okay, so let's go look at it. This area model, notice it's already kind of partially been done for us. I've got a 500, 30, and a 6, so I have my expanded form. So I'm just going to highlight for a second. We've got our expanded form of the 536. That 4 is out front. And we've got the biggest box here, slightly smaller. So we're going to start off by taking 4 times 6. So this box will be 4 times 6, which is 24. This one, 4 times 30, which is 120. And 4 times 500 is 2,000. Now, I guess I should kind of take a break for a second and let you guys know that this is 4th grade. slash fifth grade, but mostly fourth grade at this point. And what's happening here is that students will have practice 4 times 30. So they'll probably have a bunch of sprints where they practice 4 times 20, 4 times 30, 4 times 40, you name it. They're going to go down it. So they're going to know that I just multiply the first two numbers and add a zero. So although that may seem weird to us right now, taken out of context, they'll have practiced that skill before they're going here. Okay, now, how do we finish this off? Well, we're going to stack and add. So you can stack this way, or you could stack this way. The big thing is you want to make sure that you're lining up the ones digit, tens digits, hundreds, and thousands. And it looks like we're going to get 2,144. No matter which way we look at it, that's what I'm getting. Now, as you can see down here, it says find it with a standard algorithm. Excuse me. So what happens here is that with a standard algorithm, remember we take 4 times 6 is 24. So what we're going to teach students is that we're going to write a 4 but carry a 2. Okay, well, let's talk about what happened. That 24 is right here. That is writing the 4 and carrying the 2. Or you can actually see it better in this example. I'm writing down the 4 and carrying the 2 to the tens place. 4 times 3 is 12. 2 more is 14. So I write a 4 and carry a 1. Notice here that 12, 2 more is the 4, the 1 carries to the next line. And then finally, 5 times 4 is 20. 1 more is 21. So I'm seeing that 20 and the 1. So we're going to go ahead and look at the next slide here. So I want to go ahead and do one more of these. What happens if an area model is not given? So we want to make sure that we draw a skinny rectangle. We're going to have our biggest, that's going to be our 1,000, next to 600, 20, and 30. And so we'll just kind of make them a little bit as they're getting bigger sizes. That 8's going to go out front. Pro tip, you want your students to start from the 1. So even though we read left to right, we're going to actually do this right to left because we want them to remember to always start with a ones place when they're multiplying and kind of keep moving forward to bigger positions. So here I'm going to get 3 times 8, 8 times 20, 8 times 600, so that'd be a 48 with 2 zeros. And then lastly, 8 times 1,000, that'd be an 8 with 3 zeros. So again, those shortcuts, if I just remind you guys of the shortcut for 8 times 600, you're multiplying the 8 and the 6, and then you're adding the 2 zeros to the end for your answer there. We're not done though. We need to stack and add. So I'm going to stack. So we've got 4, 8, 9, and then 12. So it looks like it's 12,984 is our answer. Okay, now it says down here, find the product using the standard algorithm. Notice the carrying and how it matches with the area model. So what's happening here is that when I multiply 8 times 3, this is the 4, the 2 is what I'm carrying. So let me mimic that down here one more time. 8 times 3, 4, carry the 2. So here's my 4, and here's what I carried. Okay, 8 times 2 is 16. Okay, here's my 16. And then 2 more, so there's that 2 more, is 18. It's hard to do when I keep stopping. Okay, 8 times 6 is 48. You can see that 48. 1 more will be 49. So there's that 1 more. Sorry, 1 more. My bad. And then 8 times 1 is 8. 4 more is 12. I just do math, but I keep pausing and stopping in the middle of it. All right, so there it is. All right. Next up, we're going to look at multiplying 2-digit numbers and what those area models look like. digit multiplication. So again, when I looked at the teacher resources in the Common Core curriculum, this is what I saw. Okay, so one of the things that I noticed is that instead of having a skinny rectangle, it's more like a square that's been dissected. So we have our top number is written across the top in expanded form. So I've got this 26, so it will go 20 and 6. Okay. The bottom number is also written in expanded form. It's written on the outside. So let me actually, and I know that you can see the picture right there, but what we have is 20 and 6, and then 4 and 30. When we go to cut it, we're going to cut it kind of smaller on the ones and smaller on the ones. And that's what kind of gives this offset sort of picture. And then all we're going to do with these area models is we're going to find the area of each of these little boxes. So 6 times 4, 4 times 20, 6 times 30, and then 20 times 30. 20 times 30 would be a 6, and then we'd have 2 zeros that we'd want to add to it. Now, what this is called 4 partial products. Okay, so here it is. Each box in the grid represents 4 partial products. It's true, it is 4 partial products. However, this right here is what we want to get to because this is our standard algorithm. So I'm going to go ahead and show you that even though I'm creating 4 partial products, I think the best way to go after this step is to add straight across. If I add 80 and 24, I get 104. And if I add 600 and 180, I get 780. And then I get basically, these are called my 2 partial products that I'm going to add down. Why is this a good thing to do? Well, first off, it's great because it's visual, it's small. Students are doing small little products, which seem to go faster and then gluing them together, okay? But this is our standard algorithm that we want to get students to, and I want to tell you what's difficult about this standard algorithm, okay? The first number is not so awful. 4 times 6, 24, carry the 2. 4 times 2 is 8, 2 more is 10. And notice that 104 matches our straight across of 104. Here comes the glitchy part. Are you ready? You've been taught to add a 0 here or a placeholder, and we go 1 over. We've been told to do this. Why? Why do we have to do this? Okay, well, here's why. Even though we're multiplying by 3, I'm going to take 3 times 6 and then 3 times 2. That 3 is technically a 30. So that's why that 0 is there, guys. That 0, when we go to that next row, is there because I'm not just multiplying by 3. This is 30. 30 times 26. Okay, so that 3 times 6 is an 18, carry 1, and then 3 times 2 is 6, 1 more is 7. So again, I get the same 2 partial products, but all I'm going to do is fill in these 4 boxes and then go straight across adding, and we'll get to the same step that we were getting with the standard algorithm. So to parents, this looks like, shooting an ant with a cannon. For those who are in the Common Core, it's like, oh, okay, we're just showing that each number has a place value, that we can find these small products and glue them together to get our big answer. So let me show you that this really isn't that awful. I'm going to do a couple problems start to finish so you can see it in action. Okay. So here's one. They've already kind of drawn the box for us. So the first thing I'm going to do actually over here is write my 62 times 35. Okay. So that 62 is what's going to go across the top. 62. Now, I'll be honest with you, the hardest part for me is writing this 35 on the side because I want to write 30 first and 5 on the second. But you want to write the ones first and the 30 second. It matters. And the reason why it matters is to match the standard algorithm. You want the ones up top and you want the tens down on the bottom. Okay. All right. Now, I promise you guys it wasn't going to be that hard to do. So once we have it set up, we're going to go ahead and find these 4 small products. So 4 partial products. So 2 times 5, 60 times 5. So 6 times 5 is 30. Add a 0, 300. Next row. 2 times 30, 60 times 30. So 6 times 3 is 18. And we're going to add 1 0 and one more zero, so 2 zeros. Okay. Now, here is the key for having it match our standard algorithm. Add across the top. So 300 plus 10, 1800 plus 60. All right. Add down. And 3 is 11. Sorry about that. There we go. 2,170. Awesome. Now down here it says find the product using the standard algorithm. I mean, sure, what I'm trying to show you is that we are still doing the standard algorithm. All we're doing is taking this 310 in two little parts and this 1,860 in two little parts. It really is not that much longer of time than what you normally do. Okay, one more. Let's go for it. So again, if we're going to do 54 times 23 as it looks here, in fact, I already wrote it, but that's okay. I'm going to write it one more time because why not? Okay, so I'm going to write that 54 across the top, and then 3 goes first and 20 goes second. That is the hardest part for me. I want to write the 20 first and 3 second. All right, here we go. Filling in those little boxes. 3 times 4. 3 times 50. So that'd be 15, add a 0. 4 times 20. 50 times 20. This one's a little bit trickier. 5 times 2 is 10. And then I still need to add the 2 zeros. Okay, ready? We're going to add straight across. And add straight across. Okay. No. We would down. Looks like I'm going to get 1,242. Okay. Now here's the crazy part. The Common Core textbook, you'll see stuff like this. And again, as parents, we might kind of panic. As teachers, we're not going to, because what this is doing is we want students to realize that this is 3 times 54. So that 162 that I just found is 3 times all of this, 54. And this 1,080 is not 2 times 54, it's 20 times 54. All right, so we're just trying to make the connection that it's not just the digits that are important, it's where they're at, because that's representing a place value. Final thoughts. Area models are very weird to parents and caregivers who've never seen math done this way. And this is a hot topic, a hot button that gets hit where, why are they teaching math this way? We're just trying to help students visualize place value and the importance, okay? As future teachers, I want you guys to demystify it for them. Explain why students are learning this way. I think a lot of the anger that happens is uncomfortableness and just not understanding. And so if you just take a minute to go, look, the kids are learning the same math. We're just introducing it a different way. I think it'll go a lot further. You'll get a lot less antagonism, okay? And yes, of course, kids are still learning that standard algorithm. Okay, so standard algorithm being the old way we do stuff. Yeah, they're still doing that, guys. They're just doing a different step first to show why it works. All right, try some more of these problems. I hope it goes well for you. And next class, or next video, I should say, we are going to be doing long division and how they tackle that with Common Core. So look for it, and I hope you have a great day until then. Have fun doing math. Bye-bye.